Hi everybody, welcome to chapter 26, which is the digestive system. So in this chapter we're going to talk about the structures and the functions of the digestive system. As you can see on the slide, it tells you some of the major functions, and when you think of those functions, think of eating a piece of candy or something. And the first thing you have to do is you have to move materials into the body, and so that's ingestion. Motility is the movement of that material, so moving the material around in our mouth when we are actually breaking it down, moving it through the esophagus, through the into the stomach, moving it in the stomach while it is broken down further, stuff like that. Secretion, we are releasing enzymes to help break down the food. We start secretions in the mouth with salivary amylase and saliva, and we continue to secrete in our stomach and in our intestines to help break down material. Oh, whoa, that was fast. The next thing would be digestion. So there's two types of digestion that we typically do. Mechanical digestion is physically breaking down materials by chewing or by mixing. So we chew from our mouth, and then in our stomach, we're mixing materials until it forms a small, very, very dilute liquid food called chyme. Absorption then occurs in the intestines, most of it in the small intestines, where we take in those nutrients from the food that we ate. And then elimination is getting rid of all of the waste product. So the digestive system has two major parts. We have the GI tract, which contain all the actual organs of the digestive tract, and then we have the accessory organs. So the GI tract is similar to, I always like to compare it to a straw. It's a long, hollow tube. So it starts in the mouth. Food moves into the mouth, moves down through the pharynx, oro and laryngopharynx, into the esophagus, through that diaphragm, so through that entire thoracic cavity, and into the stomach. From the stomach, food moves into the small intestines. Food here is going to get broken down to the point where we can absorb the nutrients, and then it moves into the large intestines. Any excess materials that we want to reabsorb, or not reabsorb, to absorb, occurs in this large intestine, including all the fluids, waters, and then waste products come out through the anus. But we have a lot of accessory organs that help us in this process. So starting in our mouth, we have teeth that help to break down food. We have a tongue that helps to move food around. We have salivary glands. Salivary glands produce saliva that are necessary not only for helping with breakdown of food, but also with helping us to be able to taste the food and to clean our mouth. There's also chemicals in saliva that help to reduce pain in our mouth. Move down, we have in the abdominal cavity, we have the liver and the gallbladder, this little green thing. The liver produces bile. It also takes in and sorts the materials that are brought in from the intestines. It detoxifies materials, and then it can store nutrients or it can send nutrients out, depending on what we need to do. Bile then is stored in the gallbladder, and so the gallbladder's main job is just to store it, help to concentrate the bile, and then release it when we need it into the small intestines. And then we have the pancreas, which is this little organ right down here. I think it'll be, oh, I don't have a thing on there, but you can see it right here. There's the pancreas. The pancreas is both an endocrine and an exocrine organ. We've talked about it in the endocrine system because it has major functions, producing insulin, glucagon, and some other hormones. In the digestive system, it produces many of the enzymes that break down proteins, fats, and nucleic acids. Proteins, fats, nucleic acids. Oh, and carbohydrates. I don't know why I couldn't think of that one. Sorry. And then we have the appendix, which is not so much an accessory organ as a vestigial organ, but it does have some very important functions still. Oh, no. Hold on. Sorry. So this is a video, but I'm not going to watch it. You can watch this. This is just a fun video if you want to watch it. You don't have to. It shows the movement of materials through the entire digestive tract. When we look at the digestive system, there are 4 major layers. Most internally, we have the mucosal layer. The mucosal layer contains your simple columnar epithelium that is that has a mucous membrane around it, as well as some stratified squamous epithelium. We have the submucosa, the muscularis, and the serosa. Within the submucosa and the muscularis, we have a nerve plexus called the enteric nerve system. The enteric nervous system is the gut's nervous system. It has been likened to a second brain, and it has a lot of really important functions. So the major function that we typically focus on is the fact that it moves materials through the digestive tract, and it stimulates secretions of materials into that lumen, and it can help in controlling the sphincters throughout the digestive tract, so it helps control the movement, so how fast or how slow. It also activates and inactivates the digestive system. So when we don't need to have our stomach rumbling, then it's going to stop that. The enteric nervous system has more functions than just that, though. It also produces some of the neurotransmitters that stimulate health and well-being. And so you'll watch a movie at some point on the enteric nervous system and how important it actually is. And hopefully you'll get some information about some of the things we can learn about the gut and the enteric nervous system and the gut itself, and how it could influence health of even the nervous system, the brain. So we're going to go over the upper GI tract in this first lecture. We're going to start at the oral cavity, and then we're going to go through to the stomach. The oral cavity is that mouth, and within that mouth we have the tongue, and we have salivary glands, and we have teeth. So we're going to look at all of those. The function of the oral cavity is to take in or ingest materials, break those materials down until it is what we call a soft food bolus. A bolus of food is a basically the chunk of food that you put into your mouth that has been mechanically broken down and formed into a soft ball. That's what a bolus is. That can then be swallowed and moved down through the esophagus. The esophagus is the next tube then. So as the food moves from the mouth into the pharynx, which is our throat, the esophagus then will take the food and move it to the stomach. So the esophagus is a tube that connects the pharynx or throat to the stomach. And the esophagus moves materials through a peristaltic motion, so smooth muscle contractions, from the throat or from the pharynx and into the stomach. This trip takes a very short period of time. And once we get to the stomach, then that bolus is going to be broken down even further through a process called gastric churning or mixing. And so this is where we have 3 layers of smooth muscle that continuously contract and relax, causing the secretions in the stomach to mix with that bolus until it is broken down into a liquid food called chyme. So let's look at the oral cavity a little bit closer. Oral cavity contains our teeth, is our mouth. Starts at the lips. The lips are stratified squamous epithelium, non-keratinized. Then we have our teeth, which are embedded into our gums or gingiva. The tooth and jaw joint is known as a gomphosis. We have our tongue, which is connected right here at this lingual frenulum. So it holds the tongue to the bottom of our mouth. And the lips are actually attached by a labial frenulum up here to our gums. The back of our mouth is a uvula. The uvula hangs off that soft palate, and it flips upwards and covers the nasopharynx when we are eating food, so that food doesn't come out our nose. The tongue is a really important muscle of the digestive system, so it has a lot of different functions. It helps us with talking. You know that the tongue has the receptors for taste, because you've all tasted food. But the tongue also helps us with eating food. So without our tongue, we wouldn't be able to manipulate food properly. Our tongue also helps us in pushing the materials to the back of the mouth. The tongue is held in place by this lingual frenulum. If you've ever heard of the term tongue-tied, that's a real thing, where this lingual frenulum is a little bit too tight, and they have to slash it a little. Actually, my grandson has this problem, and we'll be having a surgical procedure where they will cut that lingual frenulum. And so here you can see the mouth all labeled. We also have we do have tonsils, but we also have, I'm not going to talk about tonsils here. I'll talk about the salivary glands though. So we have a lot of salivary glands that produce saliva that help with producing that food bolus, as well as helping to break down food and cleaning our mouth. So let's talk about the saliva. Saliva is produced continuously by mucus cells within the salivary glands. The cells produce saliva, and saliva consists mainly of water, but it does have enzymes and antibodies, as well as some other materials. So we're producing saliva continuously, but the majority of the saliva that we produce occurs during mealtime. So when you're sleeping at night, you don't tend to produce as much saliva, which is why typically when you wake up, if you're going to have a dry mouth, it usually occurs right as you first wake up. Saliva has salivary amylase in it, and salivary amylase helps to break down materials. There are also enzymes like lysozyme, as well as antibodies that help to break down any potential bacteria that are in the food or in the mouth. And then there are some enzymes that eliminate pain. So when you have a sore in your mouth, the amount of pain that sore causes is actually lessened. Your mouth is super sensitive, which is why any tiny little sore can cause serious pain, but it also heals faster and the amount of pain that is associated with the mouth is always lessened by some of the materials within the saliva, pain-reducing materials. Mastication is then chewing. So mastication occurs typically with teeth. That's what we think about. But even as an infant, we chew with our gums. And so the types of foods we eat definitely differ from infancy to adulthood. Mechanically chewing food helps to increase the surface area of the food. And it helps promote salivation. So the more we chew, the more saliva we produce. This is why at the end of a day, when people are, not at the end of a day, at the end of a meal, a lot of times people will take out a piece of gum. Gum actually helps to clean your teeth and your mouth because it produces more saliva. Teeth are the major organ for chewing or mastication. This is a tooth right here. Teeth are also known as your dentition. Humans have two sets of teeth that we receive. We have all the teeth in our jaw prior to birth, but the teeth will erupt at different times in our life. The first set of teeth are called our milk teeth or our baby teeth, and then the second set of teeth are our adult teeth. Both are super important, so it's not like, oh, they're just baby teeth. It doesn't matter if they get a cavity. That's not true. A cavity in a baby tooth can cause damage to adult teeth as well. Teeth have, the part of the tooth that you typically see is called the crown, and surrounding that crown is a thick layer of enamel. We don't produce new enamel, so the enamel that you have is the enamel that you get. So you don't want to damage that enamel. Deep to the enamel is the dentin. This is a seriously hard material that helps to, well, keep our teeth strong. The joint between the tooth and jaw is held in place by a periodontal ligament, and it's called the gomphosis, which is a dense regular connective tissue joint that has no movement, so it's a synarthrosis. I already talked about these things. Oh, I did not talk about the cavity. So here we have the pulp cavity. This is where blood vessels come in. So here's the root canal carrying blood vessels in that nourish the tooth, and nerves. So your teeth all have very important nerves that sense damage to the tooth. So that's why when you have a cavity or when you have a chipped tooth, it hurts so much. And I just talked about the root canal, so I'm going to move to the next one. Here's a larger picture of a tooth. You can see that pulp cavity and all the nerves and blood vessels in it. If you have to have a root canal, they have to kill that nerve. So what happens is the tooth has died, and they're going to have to put a fake tooth in, or they're going to have to remove the damaged tooth, the broken dead tooth, and pack that area with something. But before they can do that, they have to kill that nerve, and that's what a root canal does, is it kills the nerve so that you don't have pain anymore. It's a very painful process. I've never had it, but I have had friends and family that have had that done. So we have two sets of teeth, like I said, baby teeth or deciduous teeth, and then permanent teeth or adult teeth. The baby teeth are also known as your milk teeth, and they typically start coming out anywhere from 6 to 12 months, sometimes a little later. And you typically have all of your baby teeth by the time you are 3 years old, so 2.5 to 3 years old. These teeth are going to fall out anywhere from 5 to 6 years of age and be replaced by permanent teeth. We have more permanent teeth than we have baby teeth. Our mouth typically is large enough to fit at least 28 of these teeth. The last teeth that come in are wisdom teeth. Sometimes people don't have the room for these to come in. And when that happens, that's usually caught, or if they can't fit, that means that they are impacted. They are not able to break through that bone, or they're going to damage other teeth, and then they have to be pulled. Some people do have wisdom teeth that come in just fine, and some people are born without any wisdom teeth. So by the time we are hitting puberty, most of our permanent teeth have already come in. It's the wisdom teeth that are the only ones that still have to erupt, and they come in typically anywhere between 18 and 24, 26 years of age. And so here you can see the different types of baby teeth that we have, and roughly when they show up. So this is a skull of a young child that has the baby teeth. I'm sorry, I'm going baby teeth up here. The baby teeth here, and then you can see all of the adult teeth as well that are waiting to erupt through that jawbone. So this is what it looks like. So if you have damage to, say, this baby tooth, then that can actually lead up to damage to this tooth. Or if you, so like this happened to my child, if this tooth gets pushed into the jaw for, because they're playing on a trampoline and they hit something really hard and the tooth gets impacted into the jaw, it can actually damage the tooth above as well, and that actually happened to my daughter. So very interesting though. So teeth are held in place by the periodontal ligament, and the structure that surrounds the tooth and the bone is called gingivae. Gingivae is dense irregular connective tissue. It has a stratified squamous epithelium that surrounds it. So the gums that we see are stratified squamous epithelium with underlying dense irregular connective tissue. And then each of the sockets is known as an alveolar socket, where the tooth actually hits. The gums should come all the way up to the tooth, and there should be a very tight connection between the gum and tooth, which is why we typically just use a floss to move in and get anything that has gotten in between the gum and tooth. But if the gums start to erode or start to degrade because we're not taking care of them as well, that can lead to, I guess I don't have a picture of that, I'm sorry. That can lead to gingivitis. Gingivitis is when your gums are red, sore, bleeding, and they can start to pull away from the tooth. Typical gingivitis is something that we can fix. If you see that your gums are getting red or sore or swollen, you can start brushing your teeth better. Make sure that you're getting in between the tooth and gum region with floss, and see your dentist. Because if you don't, this can lead to other gum diseases and eventually periodontal disease, where that periodontal ligament starts to break down and the tooth becomes very, very loose and falls out. So that's really dangerous. The next region then is the pharynx. The pharynx is just the throat. There's three sections: the nasopharynx, the oropharynx, and the laryngopharynx. We only use in the digestive system the oro and the laryngopharynx, which is composed of stratified squamous epithelium on the outer layer. We want it to be stratified squamous epithelium and not something else, because materials, when they move into the throat, sometimes can still be sharp. Think of that potato chip that you didn't chew all the way and it scraped the back of your throat and it hurt really bad. If you had a single layer of epithelium, that could actually break through and cause you to bleed into your throat, and that would be dangerous. The esophagus then is a tube that moves from the throat or the pharynx to the stomach. The tube has two different sphincters, an upper esophageal sphincter and a lower esophageal sphincter. Where the esophagus moves through that diaphragm is called the esophageal hiatus, and if you've ever heard of a hiatal hernia, that's when the stomach actually moves into the thoracic cavity. And so you can see it a little bit better here. Right here would be the inferior esophageal sphincter, which controls movement of materials into the stomach and makes sure that materials in the stomach don't come back out. The esophagus is also lined with stratified squamous epithelium, non-keratinized. It has a mucous membrane, and it has a lot of mucous neck glands mucus glands that secrete mucus into the esophagus to help material move more smoothly. So there are three basic phases to swallowing food. The first phase is called a voluntary phase. When food is in your mouth, we can voluntarily push it to the back of our mouth. Once it hits the back of our mouth or to our throat, it is no longer voluntary. Have you ever, and so, yeah, I always like to say this because it happens to everybody. When you're chewing food and you push the food to the back of the mouth by accident, or so I won't say chewing food, think of a piece of candy or a piece of gum. You're chewing it and it moves to the back of the mouth by accident, and then you involuntarily swallow it. Once it hits the back of the throat, you swallow and it's gone. That's because it moves into this pharyngeal or involuntary phase when it hits the throat. Then you no longer have control over that food. And from there, once it gets into the esophagus, it's going to move through peristaltic waves to the stomach. So a disorder associated with the esophagus is called gastric reflux or heartburn. That's another name for it. Everybody has probably suffered from heartburn at some point in time. And so when you look here, this is a stomach that has gastric juice. Gastric juice is highly acidic, has a pH of about 1. And here we have the esophagus. That esophageal sphincter, lower esophageal sphincter, is closed. If that sphincter opens, gastric juice can move out. Gastric juice in the esophagus is not normal, and so it causes pain or damage to receptors for pain, and will send signals stating that there's something wrong, and it can damage that tissue here. So typical heartburn that you feel once in a great while is probably not an issue, but if it occurs more often, then you're going to want to change your normal lifestyle. So the reasons people sometimes feel heartburn is because you have a really large meal. So think of, I always use Thanksgiving dinner because it tends to be a really large meal and most people understand this. So when you eat a lot of food, you're putting food into your mouth, swallowing, that's causing the gastric juice to rise. If the gastric juice rises enough and you're still eating, as that food is moving in, some gastric juice can move out. Another reason this can happen is because you have a large meal and then you lay down. And so now that gastric juice is at this region called the cardia of the stomach. And if that esophageal sphincter opens at all, it can move out. Okay, that was weird. We often see this in individuals who are pregnant. If you are overweight, if you're a smoker, or if you have eaten really large meals, those are the times we typically see gastric reflux. Don't want to do that. I'm going to go here. But the major problem is when this becomes chronic. So when you have a lot of gastric reflux, so continuous gastric reflux multiple times each week, that can lead to GERD, or gastroesophageal reflux disease. So this can actually build up scar tissue, which you can see right here. When you have scar tissue built up, this can cause problems with the movement of materials from the esophagus into the stomach and from the stomach into the esophagus. Well, so we never want food to move into the esophagus, but what happens is if that lower esophageal sphincter is damaged, it sometimes doesn't close all the way. And then anytime you have food in your stomach, that fluid can actually move out and into the esophagus. And so typical treatments are going to use lifestyle changes, definitely, food changes, and they're going to probably give you something that is going to decrease the amount of gastric juice you produce. One of the major issues with GERD is that you can actually form esophageal cancer. So the esophagus is composed of stratified squamous epithelium as its outer layer, and it has that nice thick mucous membrane, but the stratified squamous epithelium is not made for handling that acidic environment. And so instead, the tissue could convert to small intestine tissue that is able to handle that different material, that lower pH. And this can also increase your chance of cancer forming. I'm going to stop here, even though I said I was going to get into the stomach, because this has been 32 minutes and I want to get this one uploaded. I'll start in the stomach and get into the small intestine in the next video. Bye.